Appendix C. Personal Fall Arrest Systems, Non-Mandatory Guidelines for Complying with 1926.502 I. Test Methods for Personal Fall Arrest Systems and Positioning Device Systems. A. General. This appendix serves as a non-mandatory guideline to assist employers comply with the requirements in 1926.502 Paragraphs B, C, D, and E of this appendix describe test procedures which may be used to determine compliance with the requirements in 1926.502 16. As noted in Appendix D of this subpart, the test methods listed here in Appendix C can also be used to assist employers comply with the requirements in 1926.502 3 and 4 for positioning device systems. B. General conditions for all tests in the appendix to 1926.502 1. Lifelines, lanyards, and deceleration devices should be attached to an anchorage and connected to the body belt or body harness in the same manner as they would be when used to protect employees. 2. The anchorage should be rigid and should not have a deflection greater than 0.04 inches, 1 mm when a force of 2,250 pounds, 10 knots, is applied. 3. The frequency response of the load measuring instrumentation should be 500 Hz. 4. The test weight used in the strength and force tests should be a rigid, metal, cylindrical or torso-shaped object with a girth of 38 inches plus or minus 4 inches, 96 centimeters plus or minus 10 centimeters. 5. The lanyard or lifeline used to create the free fall distance should be supplied with the system, or in its absence, the least elastic lanyard or lifeline available to be used with the system. 6. The test weight for each test should be hoisted to the required level and should be quickly released without having any appreciable motion imparted to it. 7. The system's performance should be evaluated taking into account the range of environmental conditions for which it is designed to be used. 8. Following the test, the system need not be capable of further operation. C. Strength test. 1. During the testing of all systems, a test weight of 300 pounds plus or minus 5 pounds, 135 kilograms plus or minus 2.5 kilograms, should be used. See paragraph B, 4 of this section. 2. The test consists of dropping the test weight once. A new and used system should be used for each test. 3. For lanyard systems, the lanyard length should be 6 feet plus or minus 2 inches, 1.83 m plus or minus 5 centimeters, as measured from the fixed anchorage to the attachment on the body belt or body harness. 4. For rope grab type deceleration systems, the length of the lifeline above the centerline of the grabbing mechanism to the lifeline's anchorage point should not exceed 2 feet, 0.61 meters. 5. For lanyard systems, for systems with deceleration devices which do not automatically limit free fall distance to 2 feet, 0.61 m or less, and for systems with deceleration devices which have a connection distance in excess of 1 foot, 0.3 m, measured between the centerline of the lifeline and the attachment point to the body belt or harness, the test weight should be rigged to free fall a distance of 7.5 feet, 2.3 meters from a point that is 1.5 feet, 0.46 m, above the anchorage point, to its hanging location, 6 feet below the anchorage. The test weight should fall without interference, obstruction, or hitting the floor or ground during the test. In some cases, a non-elastic wire lanyard of sufficient length may need to be added to the system, for test purposes, to create the necessary free fall distance. 6. For deceleration device systems with integral lifelines or lanyards which automatically limit free fall distance to 2 feet, 0.61 meters or less, the test weight should be rigged to free fall a distance of 4 feet, 1.22 meters. 7. Any weight which detaches from the belt or harness has failed the strength test. D. Force test. 1. General. The test consists of dropping the respective test weight once as specified in paragraph D2I or D3I of this section. A new and used system should be used for each test. 2. For lanyard systems. I. A test weight of 220 pounds plus or minus 3 pounds, 100 kilograms plus or minus 1.6 kilograms, should be used. See paragraph B4 of this appendix. 2. Lanyard length should be 6 feet plus or minus 2 inches, 1.83 m plus or minus 5 centimeters, as measured from the fixed anchorage to the attachment on the body belt or body harness. 3. The test weight should fall free from the anchorage level to its hanging location, a total of 6 feet (1.83 meters) free fall distance, without interference, obstruction, or hitting the floor or ground during the test. 3. For all other systems. A test weight of 220 pounds plus or minus 3 pounds, 100 kilograms plus or minus 1.6 kilograms, should be used. See paragraph B4 of this appendix. 2. The free fall distance to be used in the test should be the maximum fall distance physically permitted by the system during normal use conditions, up to a maximum free fall distance for the test weight of 6 feet (1.83 meters), except as follows. A. For deceleration systems which have a connection link or lanyard, the test weight should free fall a distance equal to the connection distance, measured between the centerline of the lifeline and the attachment point to the body belt or harness. B. For deceleration device systems with integral lifelines or lanyards which automatically limit free fall distance to 2 feet (0.61 meters) or less, the test weight should free fall a distance equal to that permitted by the system in normal use. For example, to test a system with a self-retracting lifeline or lanyard, the test weight should be supported and the system allowed to retract the lifeline or lanyard as it would in normal use. The test weight would then be released and the force and deceleration distance measured. 4. A system fails the force test if the recorded maximum arresting force exceeds 1,260 pounds, 5.6 knots, when using a body belt, and/or exceeds 2,520 pounds, 11.2 knots, when using a body harness. 5. The maximum elongation and deceleration distance should be recorded during the force test. Deceleration device tests. 1. General. The device should be evaluated or tested under the environmental conditions, such as rain, ice, grease, dirt, type of lifeline, etc., for which the device is designed. 2. Rope grab type deceleration devices. Devices should be moved on a lifeline 1,000 times over the same length of line, a distance of not less than 1 foot, 30.5 centimeters, and the mechanism should lock each time. 2. Unless the device is permanently marked to indicate the types of lifeline which must be used, several types, different diameters and different materials of lifelines should be used to test the device. 3. Other self-activating type deceleration devices. The locking mechanisms of other self-activating type deceleration devices designed for more than one arrest should lock each of 1,000 times as they would in normal service. 2. Additional non-mandatory guidelines for personal fall arrest systems. The following information constitutes additional guidelines for use in complying with requirements for a personal fall arrest system. Selection and use considerations. 1. The kind of personal fall arrest system selected should match the particular work situation, and any possible free fall distance should be kept to a minimum. Consideration should be given to the particular work environment. For example, the presence of acids, dirt, moisture, oil, grease, etc., and their effect on the system should be evaluated. Hot or cold environments may also have an adverse effect on the system. Wire rope should not be used where an electrical hazard is anticipated. As required by the standard, the employer must plan to have means available to promptly rescue an employee should a fall occur, since the suspended employee may not be able to reach a work level independently. 2. Where lanyards, connectors, and lifelines are subject to damage by work operations such as welding, chemical cleaning, and sandblasting, the component should be protected, or other securing systems should be used. The employer should fully evaluate the work conditions and environment, including seasonal weather changes, before selecting the appropriate personal fall protection system. Once in use, the system's effectiveness should be monitored. In some cases, a program for cleaning and maintenance of the system may be necessary. Testing considerations. Before purchasing or putting into use a personal fall arrest system, an employer should obtain from the supplier information about the system based on its performance during testing so that the employer can know if the system meets this standard. Testing should be done using recognized test methods. This appendix contains test methods recognized for evaluating the performance of fall arrest systems. Not all systems may need to be individually tested. The performance of some systems may be based on data and calculations derived from testing of similar systems, provided that enough information is available to demonstrate similarity of function and design. C. Component compatibility considerations. Ideally, a personal fall arrest system is designed, tested, and supplied as a complete system. However, it is common practice for lanyards, connectors, lifelines, deceleration devices, body belts, and body harnesses to be interchanged since some components wear out before others. The employer and employee should realize that not all components are interchangeable. For instance, a lanyard should not be connected between a body belt or harness and a deceleration device of the self-retracting type, since this can result in additional free fall for which the system was not designed. Any substitution or change to a personal fall arrest system should be fully evaluated or tested by a competent person to determine that it meets the standard before the modified system is put in use. D. Employee training considerations. Thorough employee training in the selection and use of personal fall arrest systems is imperative. Employees must be trained in the safe use of the system. This should include the following: application limits, proper anchoring and tie-off techniques, estimation of free fall distance, including determination of deceleration distance and total fall distance to prevent striking a lower level, methods of use, and inspection and storage of the system. Careless or improper use of the equipment can result in serious injury or death. Employers and employees should become familiar with the material in this appendix, as well as manufacturers' recommendations, before a system is used. Of uppermost importance is the reduction in strength caused by certain tie-offs, such as using knots, tying around sharp edges, etc., and maximum permitted free fall distance. Also, to be stressed are the importance of inspections prior to use, the limitations of the equipment, and unique conditions at the worksite which may be important in determining the type of system to use. E. Instruction considerations. Employers should obtain comprehensive instructions from the supplier as to the system's proper use and application, including, where applicable, 1. The force measured during the sample force test. 2. The maximum elongation measured for lanyards during the force test. 3. The deceleration distance measured for deceleration devices during the force test. 4. Caution statements on critical use limitations. 5. Application limits. 6. Proper hookup, anchoring and tie-off techniques, including the proper D-ring or other attachment point to use on the body belt and harness for fall arrest. 7. Proper climbing techniques. 8. Methods of inspection, use, cleaning, and storage. And 9. Specific lifelines which may be used. This information should be provided to employees during training. F. Rescue considerations. As required by 1926.502 D-20, when personal fall arrest systems are used, the employer must assure that employees can be promptly rescued or can rescue themselves should a fall occur. The availability of rescue personnel, ladders, or other rescue equipment should be evaluated. In some situations, equipment which allows employees to rescue themselves after the fall has been arrested may be desirable, such as devices which have descent capability. G. Inspection considerations. As required by 1926.502 D-21, personal fall arrest systems must be regularly inspected. Any component with any significant defect, such as cuts, tears, abrasions, mold, or undue stretching, alterations or additions which might affect its efficiency, damage due to deterioration, contact with fire, acids, or other corrosives, distorted hooks or faulty hook springs, tongues unfitted to the shoulder of buckles, loose or damaged mountings, non-functioning parts, or wearing or internal deterioration in the ropes must be withdrawn from service immediately, and should be tagged or marked as unusable or destroyed. H. Tie-off considerations. One of the most important aspects of personal fall protection systems is fully planning the system before it is put into use. Probably the most overlooked component is planning for suitable anchorage points. Such planning should ideally be done before the structure or building is constructed so that anchorage points can be incorporated during construction for use later for window cleaning or other building maintenance. If properly planned, these anchorage points may be used during construction as well as afterwards. Properly planned anchorages should be used if they are available. In some cases, anchorages must be installed immediately prior to use. In such cases, a registered professional engineer with experience in designing fall protection systems, or another qualified person with appropriate education and experience should design an anchor point to be installed. 2. In other cases, The agency recognizes that there will be a need to devise an anchor point from existing structures. Examples of what might be appropriate anchor points are steel members or I-beams if an acceptable strap is available for the connection. Do not use a lanyard with a snap hook clipped onto itself. Large I-bolts made of an appropriate grade steel. Guardrails or railings if they have been designed for use as an anchor point, or masonry or wood members only if the attachment point is substantial and precautions have been taken to assure that bolts or other connectors will not pull through. A qualified person should be used to evaluate the suitable of these makeshift anchorages with a focus on proper strength. 2. Employers and employees should at all times be aware that the strength of a personal fall arrest system is based on its being attached to an anchoring system which does not reduce the strength of the system, such as a properly dimensioned I-bolt/snap hook anchorage. Therefore, if a means of attachment is used that will reduce the strength of the system, that component should be replaced by a stronger one, but one that will also maintain the appropriate maximum arrest force characteristics. 3. Tie-off using a knot in a rope lanyard or lifeline, at any location, can reduce the lifeline or lanyard strength by 50% or more. Therefore, a stronger lanyard or lifeline should be used to compensate for the weakening effect of the knot, or the lanyard length should be reduced, or the tie-off location raised, to minimize free fall distance, or the lanyard or lifeline should be replaced by one which has an appropriately incorporated connector to eliminate the need for a knot. 4. Tie-off of a rope lanyard or lifeline around an H or I-beam or similar support can reduce its strength as much as 70% due to the cutting action of the beam edges. Therefore, use should be made of a webbing lanyard or wire core lifeline around the beam, or the lanyard or lifeline should be protected from the edge, or free fall distance should be greatly minimized. 5. Tie-off where the line passes over or around rough or sharp surfaces reduces strength drastically. Such a tie-off should be avoided or an alternative tie-off rigging should be used. Such alternatives may include use of a snap hook/D-ring connection, wire rope tie-off, an effective padding of the surfaces, or an abrasion resistance strap around or over the problem surface. 6. Horizontal lifelines may, depending on their geometry and angle of sag, be subjected to greater loads than the impact load imposed by an attached component. When the angle of horizontal lifeline sag is less than 30 degrees, the impact force imparted to the lifeline by an attached lanyard is greatly amplified. For example, with a sag angle of 15 degrees, the force amplification is about 2:1, and at 5 degrees sag, it is about 6:1. Depending on the angle of sag and the line's elasticity, the strength of the horizontal lifeline and the anchorages to which it is attached should be increased a number of times over that of the lanyard. Extreme care should be taken in considering a horizontal lifeline for multiple tie-offs. The reason for this is that in multiple tie-offs to a horizontal lifeline, if one employee falls, the movement of the falling employee and the horizontal lifeline during arrest of the fall may cause other employees to fall also. Horizontal lifeline and anchorage strength should be increased for each additional employee to be tied off. For these and other reasons, the design of systems using horizontal lifelines must only be done by qualified persons. Testing of installed lifelines and anchors prior to use is recommended. 7. The strength of an I-bolt is rated along the axis of the bolt, and its strength is greatly reduced if the force is applied at an angle to this axis, in the direction of shear. Also, care should be exercised in selecting the proper diameter of the eye to avoid accidental disengagement of snap hooks not designed to be compatible for the connection. 8. Due to the significant reduction in the strength of the lifeline/lanyard, in some cases, as much as a 70% reduction, the sliding hitch knot, Prusik, should not be used for lifeline/lanyard connections except in emergency situations where no other available system is practical. The 1N1 sliding hitch knot should never be used because it is unreliable in stopping a fall. The 2N2 or 3N3 knot, preferable, may be used in emergency situations. However, care should be taken to limit free fall distance to a minimum because of reduced lifeline/lanyard strength. Vertical lifeline considerations. As required by the standard, each employee must have a separate lifeline, except employees engaged in constructing elevator shafts who are permitted to have 2 employees on one lifeline when the lifeline is vertical. The reason for this is that in multiple tie-offs to a single lifeline, if one employee falls, the movement of the lifeline during the arrest of the fall may pull other employees' lanyards, causing them to fall as well. Snap hook considerations. 1. Although not required by this standard for all connections until January 1, 1998, locking snap hooks designed for connection to suitable objects of sufficient strength are highly recommended in lieu of the non-locking type. Locking snap hooks incorporate a positive locking mechanism in addition to the spring-loaded keeper, which will not allow the keeper to open under moderate pressure without someone first releasing the mechanism. Such a feature, properly designed, effectively prevents rollout from occurring. 2. As required by 1926.502 D6, the following connections must be avoided unless properly designed locking snap hooks are used, because they are conditions which can result in rollout when a non-locking snap hook is used. I. Direct connection of a snap hook to a horizontal lifeline. 2. Two or more snap hooks connected to one D-ring. 3. Two snap hooks connected to each other. 4. A snap hook connected back on its integral lanyard. V. A snap hook connected to a webbing loop or webbing lanyard. 6. Improper dimensions of the D-ring, rebar, or other connection point in relation to the snap hook dimensions which would allow the snap hook keeper to be depressed by a turning motion of the snap hook. K. Free fall considerations. The employer and employee should at all times be aware that a system's maximum arresting force is evaluated under normal use conditions established by the manufacturer, and in no case using a free fall distance in excess of 6 feet, 1.8 meters. A few extra feet of free fall can significantly increase the arresting force on the employee, possibly to the point of causing injury. Because of this, the free fall distance should be kept at a minimum, and, as required by the standard, in no case greater than 6 feet, 1.8 meters. To help assure this, the tie-off attachment point to the lifeline or anchor should be located at or above the connection point of the fall arrest equipment to belt or harness. Since otherwise additional free fall distance is added to the length of the connecting means, i.e., lanyard, attaching to the working surface will often result in a free fall greater than 6 feet, 1.8 meters. For instance, if a 6-foot, 1.8 m, lanyard is used, the total free fall distance will be the distance from the working level to the body belt, or harness, attachment point plus the 6 feet, 1.8 meters of lanyard length. Another important consideration is that the arresting force which the fall system must withstand also goes up with greater distances of free fall, possibly exceeding the strength of the system. L. Elongation and deceleration distance considerations. Other factors involved in a proper tie-off are elongation and deceleration distance. During the arresting of a fall, a lanyard will experience a length of stretching or elongation, whereas activation of a deceleration device will result in a certain stopping distance. These distances should be available with the lanyard or device's instructions and must be added to the free fall distance to arrive at the total fall distance before an employee is fully stopped. The additional stopping distance may be very significant if the lanyard or deceleration device is attached near or at the end of a long lifeline, which may itself add considerable distance due to its own elongation. As required by the standard, sufficient distance to allow for all of these factors must also be maintained between the employee and obstructions below, to prevent an injury due to impact before the system fully arrests the fall. In addition, a minimum of 12 feet, 3.7 meters of lifeline should be allowed below the securing point of a rope grab type deceleration device, and the end terminated to prevent the device from sliding off the lifeline. Alternatively, the lifeline should extend to the ground or the next working level below. These measures are suggested to prevent the worker from inadvertently moving past the end of the lifeline and having the rope grab become disengaged from the lifeline. M. Obstruction considerations. The location of the tie-off should also consider the hazard of obstructions in the potential fall path of the employee. Tie-offs which minimize the possibilities of exaggerated swinging should be considered. In addition, when a body belt is used, the employee's body will go through a horizontal position to a jackknifed position during the arrest of all falls. Thus, obstructions which might interfere with this motion should be avoided or a severe injury could occur. N. Other considerations. Because of the design of some personal fall arrest systems, additional considerations may be required for proper tie-off. For example, heavy deceleration devices of the self-retracting type should be secured overhead in order to avoid the weight of the device having to be supported by the employee. Also, if self-retracting equipment is connected to a horizontal lifeline, the sag in the lifeline should be minimized to prevent the device from sliding down the lifeline to a position which creates a swing hazard during fall arrest. In all cases, manufacturer's instructions should be followed.